And at that time, when I bought it, then the first question are using container for your work. So how many persons are at the RubyConf India? I just wanted to know that how many they know about the container, and how many they know how to use, or what is it about the Kubernetes. Then after that, last question was is there anyone who knows about CRI, or is there anyone who ever tried to implement the CRI? And the first question, the result was a 20 to 30% Ruby users are using actually container from my quick skip of the venue. And the second question, Kubernetes, using Kubernetes person is less than 10% or something like that, 10% or something. Then the last question, so internal architecture, and so who understand and knows and try to do something about internal architecture is actually 0 was. Yes, that was the overall result of that. By the way, in this venue, how many are using container? Daily basis or the weekly or monthly is okay? Okay, or everyone, or really high level, I think. And how is Kubernetes? Is there anyone? Yes, so maybe infrastructure layer persons needs to use, right? So, but still many, I think. I was really surprised to see that numbers. And of course, no one ever touched about CRI, right? Okay, understand. So maybe skip the, but actually quick introduction is quick introduction.
CRI,
yes.
We have tried, have you heard about Facti?
Yes.
Yeah, Facti we tried to integrate with Kubernetes for some experimental purpose.
Oh, okay.
See whether we can run it directly in the hypervisor rather than sharing the kernel.
It's possible, right?
Yeah, it's possible. Yeah. We tried it. It did work.
So you are working. You are the person who is working for some Facti things, or a contributor, or?
No, not a contributor.
Okay, in your
Facti.
production environment, or for your work, you have tried. Okay.
Correct.
How was that?
Getting bare metals to run containers.
Okay.
From Kubernetes.
And you have just tried to apply or use the Facti, but
correct.
Just for something not in production yet.
Yeah, configure Kubernetes gRPC to use the Facti.
Okay,
APIs
understand. That's interesting. Maybe I want to know much more about that story, but okay, anyways, maybe my story for this time. Okay, I'm from, just in short, I'm from Japan. And I'm from, actually my hometown is Sapporo, the northern part of Japan.
Okay.
All right. So maybe I just need to tell you a little bit about container runtime interface, because maybe many persons, how do you say? I just need to how do you say? Need to make clear about your understanding. Actually, I need to make your understanding much clear about what is container runtime first. What container runtime first? Container runtime is completely equal to Docker. Then it's of course no. I think you know much about the container, so that maybe it's not a difficult question, but just to explain you. Yes, Docker is just one of implementations of container runtime, and there is another implementation such as a runC, rkt, and runv, or any other. And the most important point about the container runtime is the specification is already standardized by OCI, Open Container Initiative. So given this situation, with that specification, we can create our own container runtime if we really want, and if we have much power to do that. That's the important point. Then we understand container runtime, and what is container runtime interface? That is the next question. Then container runtime interface is the interface to use the container runtime. That's the basic explanation about that. So basically, what CRI defines and gives is a CRI provides a set of APIs you can call from client application. That's it. Basically, that's it. And in Kubernetes, it is used by Kubernetes, a kubelet, I think. And kubelet, maybe some of you have been heard about the kubelet, the word itself, but kubelet is one of a element how Kubernetes is a how it works. Anyways, the kubelet will use a CRI, and kubelet will call CRI's APIs over a gRPC. So now we understand. So container runtime is Docker is not Docker is not a one of container runtime, and there is many other implementation, and the specification is defined and it's open. And Kubernetes is using gRPC to manage a container runtime. So that is the basic understanding of that. And given this understanding, so we understand. So okay, we know CRI works over gRPC, means Kubernetes is managing the container over gRPC. So what kind of APIs are available actually is the next question. And of course, we are developer. We can really quickly see the API headers and understand what is it really. And these are the actual CRI's API definitions, which is came from a protocol buffers, a IDL. And really just to quick scheme, then there is a managing pod sandbox APIs. Actually, pod sandbox is the new word for here, and maybe many of us doesn't know about pod. But pod is a kind of a how to say combination of a containers, running containers, including networking and I/O and logging or something like that. So maybe you can see regard that to make some application, you create some pod, and in the pod you will prepare a few containers, such as, for example, sometimes HTTP server and some server for logger or something like that. So these are the basic concepts. So a minimum set of a functionality of a containers is a pod. So CRI defines the how to manage pod, and also CRI, of course, deliver the direct control to container, so that over CRI, kubelet can control container directly, and other MISC APIs. And also CRI provides a image services, which is provides a functionality of a how to handle images. So basically, which is for example, when you type Docker pod, then you can, of course, get the image from Docker Hub, and you can push, right? Something like that. So these APIs are the set of APIs to manage your container images. So list an image and remove or something like that. So very quick introduction, but CRI is something like that. So internally, Kubernetes is using CRI, and CRI provides a functionality like how to manage a pod, and how to manage container, and how a user can use a image. So these are the basic functionalities a CRI provides internally. Okay, maybe I should skip this for the time this on. And so now I can start the talk. So all the definition is already finished actually. So we know container runtime, and we know CRI, and it's okay. So let's see. So prototyping Kubernetes CRI. So okay, now we know CRI, and actually, but maybe some of you doesn't know about the Kubernetes. So maybe I need to explain. So what is Kubernetes really is this is just a very quick summarized introduction, and of course this is not all the functionality, but just for the simple explanation, Kubernetes can be used like this. And for this example, top of two lines are for some environment settings. So in this case, of course, I type gcloud, it means I'm assuming that user is using GCP. And in case of GCP, these two commands are enough to set a environment. Then internally, this gcloud command, some environmental variable on the system is set. Then by that environmental variable, kubectl's the destination server to connect is changed, and just user use kubectl. So the point here is through this kubectl command, infrastructure manager or the operator can control a cloud services without any vendor lock-in. So given these two lines for GCPs, but for example, if you want to use a Microsoft some cloud or Amazon, or of course here is a Microsoft made, then I should say Microsoft, but Azure. But anyways, yes, we can.
So it's the same here.
Yeah.
Get credentials for AKS.
Yes,
Yeah,
yes,
so
yes, yes. Those kind of things. And these two lines is what's happening is, just to summarize. First line is create Kubernetes cluster, and in that cluster, make the container running is this. So using this image, and this image is actually public repository. You can even dock up. You can do the dock up right now, but actually this is coming from the Docker Hub. So it's just open image and use this and port is like this. So this command, by this command, you can just simply run, and the other command is a kubectl expose deployment. So by this command, Kubernetes is doing the binding to networks, internal networks and external networks. So by this binding, finally I can access to the Kubernetes cluster. Without this command, I cannot. Actually, the global IP address is not given to the cluster, so that this Kubernetes cluster is just internal things like that. But isn't it that just right? So that's the point. And not only simple, but there is many other features. But actually, just the quick introduction. And this is the sequence diagram. If I explain more detail, but maybe I need to skip for the time reason. So anyways, we now understand. So we can use Kubernetes by kubectl command. So that is interesting. And given this understanding, so now today's topic is I have tried to implement the CRI server. So how was it like? And actually, this is just the quotes from my favorite anime, Kung Fu Panda 3, and Shifu Roshi said that these things, and maybe a little bit shy, so that I skip this part. Anyway, so my talk at the RubyConf India was like this. So how to create a container image and how to create our own container runtime, and how did I prototype our Kubernetes CRI. And at the RubyConf India, I also run out the time as well. And for this time, I'm almost running out my time as well. But let's talk about that. But you know container image very much, right? So maybe I can skip this, or maybe I can just show you what is happening here. So just to explain on the summary is, so the important point is, I think container images are not difficult. Actually, container images are simple and easy, but because it's just turbos, right? So if you docker pull Box from Docker Hub, and a Docker save is some export command, so you can see that it is exported as tar file, and because it's tar file, so we can just extract it. So by extract, you can see these files. It's so simple. And if you look, take a look into this that files, each files, then you can see there is some JSON, but it's also simple, right? So maybe you can even handwrite these text files. So container is not something God create, or container is something is not something super engineer is creating. Not like that. Container is super easy, I think. So that's the point here. And for this case, I create the directory here, root directory actually, and I'm not sure if there is Debian users out there, but if Debian users, and for other distribution we have other commands, but for example for Debian users, there is some command to create utility command, which is actually that is utility command to create a how to say we can have a very basic Linux file system file folders like, so if you type this and execute this, then what will happen is under the my root folder there will be you can get a etc folder or a variable folder or a bin folder or something like that. So basically the command to create another Linux file system environment is a debug structure for here, and specify some version. So and then just a compress by tar command. That is basically what I did to create container image. But for simplicity, for this case I didn't create. Actually, I didn't handwrite the JSON files, but ask Docker commands to do that. So Docker is really kind and easy way to do create a manifest or the property files, so that I just ask those tasks to Docker command. So for this case, just a Docker command did that. And this is how container image is created. And container runtime is really a little bit, or let's say really hard, I think. But not, I mean, not technically hard, I think, or I guess, or I hope. But specification is there's many specifications. So yes, we need to think about a little bit more. So, and this is a maybe just, I'm talking about the Ruby case, and I'm not sure if how much of you are interested in Ruby, so that I'm not sure if this is a good example, but maybe just in this sheet I said, I just wanted to say in the Ruby there is no container runtime implementation. That is just, of course. But the important point is most of container runtimes is implemented in Go, and actually yes, and such as a Ranch and Rocket or other container runtimes are written in Go. And so challenge here was is that possible to create it in Ruby, but actually fully OCI compatible container, creating fully OCI compatible container runtime is really it's really hard. So that I just for my trial I just used some Ruby's library, which is a library for mRuby. Then I'm not sure all of you knows about mRuby, but mRuby is less dependent, lightweight Ruby implementation is a mRuby. So anyways, I use some library to create a not OCI compatible, but some kind of container runtime. Example is this. So basically, this library provides a wrapper function to access to the Linux lower level API, such as a namespace or C groups or such as mount or something like that. So this is a kind of simulator to work as a container runtime. Of course, this is not perfect, but a very, very simple version of what container runtime is trying to do that is something like that. So I just simulated by this way. Yes, and actually it works somehow. And the last content, so prototyping a Kubernetes CRI is just do that, meaning just create gRPC server over using Ruby is just do that. And things is just I did that is my introduction. And maybe this is maybe Ruby details, so maybe we can skip here. And the learning throughout this content for me and for Ruby users is, so it looks like we can create our own CRI implementation, but there are tons of to-dos though, of course. And also, this is some wrapping up for actually something like to-dos for Ruby users. But maybe I will introduce here some of the points. So Kubernetes ecosystem is evolving rapidly. Actually, they are releasing their major version every 3 months or 4 months. It's really crazy high speed, so it's really hard to catching up, but somehow we need to do that. So anyways, so and many tooling, and of course that's why many tooling and concepts are still on the way to getting mature. So we need to do much more effort to make our operation works better actually. And so the good thing is they are doing some standardization, so that so little by little we can create better tooling or environments, I think, and that is a good news. And something not not exciting for me is many tooling are written in Go, and the Go is actually a good language, and I like to write it, but sometimes I'm feeling like, so for some cases, other tooling or other language or other way is better or something. For example, Kubernetes has I think a problem. Kubernetes have a problem like for the Kubernetes operation, actually Kubernetes operator needs to write some or too much YAML file, I think. And YAML file is, of course, a very declarative, but many actually we need to do copy and paste to make it work. Actually, so YAML file doesn't a good capability to work for example, if I want to basically use a production and staging server, same environments, but at some point it's different. So how to figure out that? So okay, is that so manually copy and paste we do, or create some tiny tool for our own? So this is the problem really. So it's not actually comfortable yet for the Kubernetes or server infrastructure operator to do their work. So, and I just introduced a few points of those problems as of now. And that's my talk. Thank you for
Thank you.
So the container runtime you wrote in Ruby, is it?
Very just like maybe mock, let's say mock version and just the sample yes version. I have uploaded that to my GitHub repository. Yes.
Any other questions? Yeah. Thanks a lot for the
Thank you.
talk.
Thank you so much for. But actually, this is not off the topic, not about these contents, but actually, I have